The Second World War was a conflict defined by innovation. New technologies were constantly being developed, each one designed to give one side an edge. In Britain, one man was thinking far outside the box. His name was Barnes Wallis, brilliant aircraft designer and engineer. A seasoned professional, driven to shorten the war. He believed strategic bombing could cripple Germany's ability to fight. Not cities or factories, he had something else in mind. Infrastructure, the source of Germany's industrial power. Wallis had a revolutionary concept, many dismissed as fantasy. A bomb that could bounce across the surface of water, skipping like a stone, a way to bypass torpedo nets protecting Germany's dams. Nets hung in the water to stop conventional weapons, but the bouncing bomb would leap over them. It would strike the dam wall directly, sink down alongside the wall, then explode at a set depth, using water pressure to amplify the blast. Audacious, seemingly impossible, it didn't come as a flash of inspiration. It was meticulous thought and home experiments. He started with his daughter's marbles and a tub of water in the garden. He watched them skip and learned the physics. The key was backspin. Give the spherical bomb powerful backspin before release, it would hug the water's surface, making controlled bounces over long distance. Elegant in concept, complex in execution with a multi-ton device. He took the idea to the military. Initial reaction was skepticism. Senior Air Ministry figures called it absurd, impractical, wasteful. Dropping a spinning cylindrical bomb from a low-flying night aircraft sounded like fiction. Wallis was persistent, utterly convinced it could work. He produced detailed calculations, models and papers, arguing his case with passion and self-belief. Slowly, he won over a few influential figures. The seed of the Dambusters raid had been planted. To understand the importance of Barnes Wallis's idea, one must look at a map of Germany, specifically the Ruhr Valley. In the 1940s, this region was the absolute heart of the German war machine. Coal mines, steelworks, armament factories, all churning out the tanks, guns, ammunition that fueled the Nazi conquest of Europe. From the massive Krupp steel plants in Essen to the countless smaller workshops, the Ruhr was an industrial powerhouse. The Allies knew that if they could disrupt this region, they could land a devastating blow. Conventional bombing raids had tried, but the area was vast and heavily defended. The lifeblood of this industrial heartland was water. The Ruhr and its surrounding rivers provided the vast quantities of water needed for steel production, cooling processes, and generating hydroelectric power. The entire system was managed by a series of massive dams, the Möhne, the Eder, the Sorpe. These were not just dams, they were symbols of German engineering prowess. They held back billions of tons of water, regulating the supply for industry and providing power for the entire region. Destroying them would do more than just cut off the water supply. It would unleash a catastrophic flood, washing away factories, railways and bridges. The strategic value of these dams was immense. Allied planners had identified them as key targets early in the war. A successful attack would cause immediate and widespread chaos. The loss of hydroelectric power would bring factories to a standstill, and the flooding would destroy transportation links. The problem was the dams were almost impossible to destroy. These structures were colossal feats of engineering. The Möhne and Eder were gravity dams, huge walls of masonry and concrete, too massive to be broken by any standard bomb dropped from high altitude. Furthermore, they were heavily defended. Anti-aircraft guns dotted the surrounding hills, and torpedo nets protected them from underwater attack. The Germans knew how vital their dams were, and they had taken every conceivable measure to protect them. This was the challenge that faced the Royal Air Force. They had a target of immense value, but no weapon capable of reaching it, let alone destroying it. This is where Barnes Wallis's bouncing bomb came in. With grudging approval from the Air Ministry, Barnes Wallis could finally move his experiments from the garden tub to the real world. The initial tests were shrouded in secrecy and began at the National Physical Laboratory's ship testing tank at Teddington. Here, Wallis and his team could refine the theory. They used catapults to launch small-scale models of various shapes and sizes into the long water tank, filming the results with high-speed cameras and analyzing every bounce and ripple. It was here that they confirmed the crucial role of backspin. Without it, the bomb would dig into the water and detonate harmlessly. With it, it would skip beautifully across the surface. These early tests proved the principle was sound. The next step was to scale up. The team moved to Chesil Beach in Dorset, a long shingle beach that provided the perfect secure location for airdrops. Old Wellington bombers were used to drop larger, inert prototypes. These early bombs were spherical, like giant cannonballs. The tests were often frustrating. Many attempts failed. The bombs would shatter on impact with the water, or they would bounce too high and erratically. The casings needed to be much stronger than anyone had anticipated. Each failure, though, provided valuable data. Wallis and his team meticulously recorded every detail, adjusting the shape, adjusting the weight, adjusting the spin rate. They were learning on the fly, solving unprecedented engineering challenges under immense pressure. As the design evolved from a sphere to its final cylindrical shape, the testing moved to a more suitable location, the Elan Valley reservoirs in Wales. The Nonygro Dam, a small disused dam in the valley, was chosen as a live target. This was the moment of truth. In July 1942, a specially modified Wellington dropped an inert but full-sized prototype. It was a partial success. The bomb hit the dam, but not with enough force to cause significant damage. More tests were needed. The project was falling behind schedule, and the pressure from the Air Ministry was mounting. Now, the final crucial series of tests took place at Reculver in Kent. By now, the weapon, codenamed Upkeep, was in its near-final form. The problem of the casing shattering had been solved. The new Avro Lancaster bomber was chosen as the delivery platform, but a new challenge arose. The bomb was so large that it couldn't fit in the Lancaster's bomb bay. The bay doors had to be removed completely, leaving the bomb partially exposed. A special mechanism was devised to spin the bomb up to 500 RPM before release. A test drop in April 1943 was a stunning success. The bomb performed exactly as Wallis had predicted, skipping across the waves before hitting its target. The weapon was finally ready. Now they just needed the men to deliver it. With the bouncing bomb proven, the focus shifted to the human element. This was not a mission for just any bomber crew. It required a unique combination of skill, courage, and discipline. The task of forming and leading this elite unit fell to Wing Commander Guy Gibson. Gibson was only 24 years old, but he was already a veteran of over 170 missions. He was a highly decorated and respected leader, known for his demanding standards and his absolute dedication to the task at hand. He was given a simple, yet daunting instruction: form a new squadron for a single, top-secret operation. He was not told what the target was, only that the training would be intense and the mission exceptionally dangerous. Gibson was given the authority to handpick his crews. He scoured the squadrons of 5-group bomber command, looking for the best of the best. He sought out experienced pilots, navigators, bomb aimers who had completed at least one full tour of duty. These were seasoned veterans, men who knew the risks of flying over enemy territory. They came from across the Commonwealth, Britain, Canada, Australia, New Zealand. They were brought together at RAF Scampton in Lincolnshire, a base shrouded in secrecy. They were designated Squadron X, their true name 617 Squadron, only being revealed later. A sense of mystery and anticipation hung over the base. The crews knew this was something different, something big. The training was relentless and unlike anything they had ever experienced before. The core skill they had to master was extreme low-level flying. For the bouncing bomb to work, it had to be dropped from a precise height of just 60 feet above the water. Flying a 4-engine Lancaster bomber that low at night was incredibly dangerous. A moment's inattention could lead to disaster. The crews practiced for hours on end over reservoirs and lakes across England. They flew over the Uppingham Reservoir, Abberton Reservoir, their wingtips seemingly just skimming the surface. Gibson pushed them hard, demanding perfection. There was no room for error. To achieve this incredible precision, their Lancasters were modified. 2 spotlights were fitted, spotlight under the nose, spotlight under the fuselage. They were angled so that their beams would converge on the surface of the water when the bomber was at exactly 60 feet. The bomb aimer's job was to watch the 2 spots of light. When they merged into a single figure of 8, He would shout now to the pilot. At the same time, the navigator had to ensure they were at the correct speed, and the bomb aimer had to release the bomb at the exact right distance from the target. This was measured using a simple but ingenious wooden triangulation device. The crews practiced these coordinated actions again and again until they were second nature. They were being forged into a precision instrument of war. The bouncing bomb, marvel of wartime engineering, officially codenamed Upkeep. It was a large metal cylinder about the size of an oil drum, weighed over 9,000 pounds. 6,600 pounds of that was Torpex. Torpex was far more powerful than TNT. It wasn't meant to pierce the dam, it used hydrostatic shock. By exploding deep underwater, right against the dam wall, engineers had to ensure survival on water impact at over 200 miles per hour. Early thin steel prototypes shattered like glass. They developed a much stronger but still light casing. They perfected a spinning mechanism, backspin of 500 revolutions per minute before release. A hydraulic motor drove a belt to spin the bomb. The backspin produced a Magnus effect, letting it skip across the water. The detonation system couldn't fire on impact. The bomb had to sink to a precise depth first. It used 3 hydrostatic pistols from naval depth charges. These were pressure-sensitive and triggered at 30 feet. A self-destruct timer was set for 90 seconds after release. There was a race against time. The raid had to be in May. Factories like Vickers Armstrong's worked around the clock. Assembly lines built the bombs. Avro Lancaster Modification Workshop, Lancaster under maintenance. Lancasters were heavily modified. Bomb bay doors were removed. Special calipers were fitted to hold the cylinder. The mid-upper gun turret was often removed to save weight. Every detail balanced performance and risk. The evening of May 16th, 1943, was clear and still. A bright full moon rising over RAF Scampton. For the 133 airmen of 617 Squadron, the waiting was over. The final briefing had been given hours earlier. For the first time, the crews were told their targets, the great dams of the Ruhr Valley. Guy Gibson laid out the audacious plan. The squadron would attack in 3 waves. The main force, led by Gibson, would strike the Mona Dam first. A second, smaller group would target the Sorpe Dam. A third wave would be held in reserve, ready to attack surviving dams or secondary targets. The mood was a mixture of excitement, apprehension, and steely resolve. As darkness fell, the heavily modified Lancasters were readied. Each one was loaded with its single, massive Upkeep bomb. The ground crews made their final checks, their faces illuminated by handheld lamps. The airmen, burdened by their flying gear, walked out to their aircraft. They exchanged final words, handshakes, quiet reassurances. They were young men, most in their early 20s, on the brink of a mission from which many knew they might not return. They climbed aboard, the roar of the 4 Merlin engines on each bomber soon shattering the evening calm. One by one, the Lancasters of the first wave thundered down the runway and lifted into the night sky. The flight path to the Ruhr was perilous. To avoid the densest concentrations of German radar and anti-aircraft defences, the crews had to fly incredibly low. They crossed the Dutch coast at treetop height, their navigators working frantically to keep them on the precise pre-planned route. Flying at such a low altitude at night was a nerve-wracking experience. The dark shapes of trees, pylons and buildings flashed past the cockpit windows. It demanded total concentration from the pilots. Despite their skill, the low-level flight claimed its first casualties before they even reached the target. Several aircraft were lost, shot down by light flak. Others were lost by clipping high-tension cables in the darkness. For those who made it through, the next challenge was locating the dams in the maze of valleys and hills of the Ruhr region. The moonlight, which was essential for the attack run, also made them visible targets for German gunners. As Gibson's formation approached the Mona Valley, they could see the formidable structure of the dam ahead, its twin stone towers standing like sentinels. The lake behind it was calm, a vast silvery sheet under the moon, but the calm was deceptive. As the first Lancaster descended to begin its attack run, the German anti-aircraft guns positioned on and around the dam opened up. Streams of deadly tracer fire stitched the sky. The final, most dangerous phase of the mission had begun. Wing Commander Guy Gibson took his Lancaster call sign G for George in for the first attack on the Mona Dam. He descended to the terrifyingly low altitude of 60 feet. The spotlights under his aircraft merged into one, indicating the correct height. Inside the bomber, the crew was a model of focused tension. The bomb aimer, John Pulford, guided Gibson onto the correct line. The roar of the engines was matched by the hammer of German flak guns. Tracer shells zipped past the cockpit. Gibson held the Lancaster steady. At the perfect moment, Pulford released the bomb. The crew watched as it hit the water, bounced 4 times and struck the dam wall before sinking. A huge plume of water shot into the air, but the dam held. Gibson had anticipated this. He knew it might take more than one bomb. His duty now was to draw the enemy's fire. As the next Lancaster, piloted by Flight Lieutenant Hoppy Hopgood, began its attack run, Gibson flew his own aircraft alongside, deliberately attracting the attention of the gunners. Despite his efforts, Hopgood's plane was hit by flak on its approach. It was engulfed in flames, but the heroic pilot held it steady long enough to release his bomb. The bomb overshot the dam, and a moment later the Lancaster exploded, killing the entire crew. The sacrifice was not in vain. The defenders' attention had been split. It was a brutal reminder of the incredible risks these men were taking. The third aircraft in, piloted by Flight Lieutenant Mickey Martin, made a perfect run. Again the bomb struck the dam and exploded. Again the wall held, but the observers noted it was now clearly weakened. The pressure was on. 2 more Lancasters, flown by squadron leader Dinghy Young, Flight Lieutenant David Maltby, prepared to attack. Young went in first, flying through the storm of defensive fire. His bomb struck true. As the water from the explosion subsided, a small crack appeared in the center of the mighty wall. The dam was on the brink of collapse. It was now up to Maltby to deliver the final blow. Maltby began his approach. Gibson, Young, Martin all flew with him, their gunners pouring fire onto the German positions to suppress them. The concentration of fire was immense. Maltby held his nerve, his Lancaster perfectly positioned. He released his bomb. It skipped across the moonlit water, struck the dam in the same weakened spot, and sank. There was a pause, and then a colossal explosion. The center of the Mona Dam crumbled. A dark, churning torrent of water began to pour through the breach. It grew from a trickle to a cataclysmic flood in seconds. Against all odds, 617 Squadron had done it. The Mona Dam had been broken. As the surviving Lancasters of 617 Squadron limped home to RAF Scampton, the scale of their achievement became clear, and their losses became clear. Of the 19 aircraft that had set out, 8 did not return. 53 airmen were killed, 3 were taken prisoner. The human cost was immense. The crews lost were among the most experienced and skilled in bomber command. Yet as news of the breached dams spread, a wave of elation swept through Britain. The Dambusters became overnight heroes. The raid was hailed as a tremendous victory, a story of British ingenuity, skill, courage. It provided a much-needed boost to public morale during a dark period of the war. The immediate impact on Germany was significant. Floods unleashed by the breached Mona Dam, floods unleashed by the breached Ida Dam, chaos in the Ruhr Valley, chaos in the Weser Valley. Water surged for miles downstream, destroying over 100 factories, damaging hundreds more, washing away 25 bridges. Power stations were flooded, farmland was ruined. The water supply essential for the Ruhr's coal and steel industries was severely disrupted. The Germans were forced to divert huge resources to clean up and repair. Tens of thousands of TOT organization workers were pulled away from building the Atlantic Wall. They repaired the dams, a diversion of manpower that arguably helped the D-Day landings a year later. In the long term, the Dambusters raid had a lasting legacy. It was a textbook example of a precision strike, proving that a small, highly trained force with a specialized weapon could deliver outsized results. It vindicated Barnes-Wallis. His persistence had paid off spectacularly. It cemented the reputation of 617 Squadron. The squadron went on to carry out many more specialist raids, using other massive Wallis earthquake bombs, Tallboy, Grand Slam, to destroy V-weapon sites, U-boat pens, the German battleship Tirpitz. The raid became one of the most famous stories of the Second World War, a powerful symbol of defiance and of innovation. It demonstrated the incredible bravery of aircrews flying at near-zero altitude under intense fire. While historians debate the raid's precise long-term strategic impact, its effect on morale in Britain and in Germany is undeniable. The Dambusters changed the war not just by destroying two dams, but by proving that with enough courage and ingenuity, even the most formidable targets could be broken. It remains a timeless tale of scientific genius and human sacrifice.